This next part of section 9.9, we're going to start out by multiplying, and the multiplying is going to be just like distributing or foiling, and then the only thing to remember is that whenever you come across an I squared, you're going to change it to -1. So I multiply. On letter A, I'm going to distribute. 2i times 5 is 10i. 2i times -3i is -6i squared. That I squared, we're going to change that to -1. And so it's going to be +6 plus 10i. So it is important that you flip the answer around so it is in standard form. Part B, FOIL. We're going to have -5 plus 15i plus 2i minus 6i squared. Combine like terms and change I squared to -1. Combine the 5 and the 6, so we have 1 plus 17i. Letter E, before I FOIL, I'm going to change those radicals into 5i and 3i, and then FOIL. And finish it out like we did on part B. Combine like terms. Change I squared to -1. So it's going to be +15 plus 3 is 18. Write your answer in standard form, which means we have the I after the 18. Dividing is also called rationalizing, and it's a lot like when we rationalized on square roots. You're going to use the conjugate of the denominator. The conjugate is the same expression with the opposite sign. So an example, a plus bi and a minus bi. And not only is it a conjugate, it's a complex conjugate, meaning that it's involving complex numbers, or the imaginary unit. So on letter A, when it says to divide, remember that divide doesn't really mean divide in the traditional sense. In this case, it means we need to rationalize by multiplying by the conjugate. So a lot of foiling going on. As we FOIL the numerator, we get 8 minus 6i minus 4i plus 3i squared. And the denominator, 16 minus 12i plus 12i minus 9i squared. And so what you'll always find is the denominator, that outside-inside part of foiling, cancels out. That's how conjugates are set up to work. Combining like terms in the numerator and changing I squared to -1. In the denominator, changing I squared to -1. So it's going to be in the numerator a -3, put with the 8 is 5. In the denominator, that's a +9. 16 plus 9 is 25. And then we have to simplify like any other fraction. So to simplify, I'm going to break this apart into 2 smaller fractions and reduce each one separately. And this also helps me to separate my real and imaginary part for standard form. So you do need to have your fractions separated. You don't want to put it back together, because standard form you have a real part and an imaginary part that are separate from one another. In part B, the conjugate in this case is going to be -3i, because when we look at like this example up here, a plus bi and a minus bi, the sign in front of the I term changes. So since this is positive 3i, we're going to change for our conjugate to negative 3i. And then I put parentheses to remind me to distribute. And I'm going to change my I squareds to negative 1. And kind of keep going here. So positive 15, and I'm going to put that first for standard form. And then this is positive 9. So I'm going to split up my fraction and simplify each fraction. That one simplifies by 3, and that one by 9. The next part that we have with I is what's called the powers of I. And so I know there's a lot up here right now. If you need to, like, pause this video so you can look at the screen a little more closely. But basically what we're going to end up finding is a repetition in the powers of I. So I to the 0 power, just like anything else to the 0 power, equals positive 1. I by itself is the square root of negative 1. We've seen that already. We've also seen that I squared equals negative 1. When we go to higher powers, I to the 3rd, what I'm going to do is I'm going to, instead of saying I to the 3rd, I'm going to say I to the 1st times I squared. It's the rules of exponents. That's the equivalent. And then I is the square root of negative 1. I squared is negative 1. So we have negative square root of negative 1, which is negative I. And so I guess the one of these that you need to remember is that one. These. And then I to the 4th, we could say I squared times I squared, which would be negative 1 times negative 1, which is positive 1. So I to the 4th equals positive 1. And then after this, we're going to continue to repeat, because you notice I to the 4th and I to the 0 both equal positive 1. I to the 5th is the same thing as I to the 1st. I to the 6th is the same thing as I squared. To the 7th is the same thing as I to the 3rd. And then just keeps repeating. So what you would do if you have some larger exponent is you divide the exponent by 4. The remainder tells which power of I is the answer. So if I to the 27th, I'm going to take 27 divided by 4. 4 goes into 27 6 times with a remainder of 3. So that remainder tells us that I to the 27th is the same thing as I to the 3rd, which is the same thing as negative I. I to the 38th is the same thing as I squared, which is negative 1.